All right, so this is notes for 5B and also the classwork answers. All right, let's get started. So our notes are up top here. They're already filled in for us, but we simplify all radicals right away. That's the first step when we're adding and subtracting radicals. We're putting them together. So the first step is to simplify all radicals. Then after each individual radical is simplified, we are going to identify which radicals have the same index and the same radicand. So just a little, probably never heard of that before. The radicand is the number under, probably should spell it right, radicand. Right, that's the number underneath the square root. And the index is like the square root or the cube root, fourth root, whatever the little number is in the little pocket here. And then step 3, for common radicals, add and subtract the coefficients and keep the common radicals. So it's very similar to variables where you add or subtract the coefficients but not do anything with the radical itself. So, all right, let's get started. So number 1, we have square root of 27. I can simplify that. That is 9 and 3. 3 is a prime number, 3 and 3. Now here we have to look at, it's a square root, so we're looking for pairs. So a pair would be a pair of 3s. So that's going to come out as a 3. There's already a 3 on the outside, so that 3 on the outside is going to stay on the outside. 3 times 3 here is 9. Square root of 9 is 3, so that's why I'm only going to write 1 3. Then there's an extra 3 over here. That is going to go underneath the square root. So this is going to end up being 3 times 3 on the outside, so it's 9 square root of 3. And then we're going to bring that subtraction down. And we're going to simplify the square root of 12. So we need to simplify that yet. So 6 times 2. Does not matter what you started with. 6 times 2, you could have done 3 times 4. It doesn't matter. We have a pair of 2s. So that's going to come down as 2. Well, let's not forget about this 2. So that 2 comes down. A pair of 2s, 2 times 2 is 4. Square root of 4 is 2. And then the square root of 3, that's left over, no pairs, so that comes down. 2 times 2 is 4, square root of 3. So now we look at step 2. Identify the radicals with the same index and same radicand. So let's look at that. So the same index, so index is the square root. So both are square roots. And then radicand, what's underneath has to be exactly the same, underneath the square root. So those are both square roots of 3, so that's good. So this is saying we have 9. There are 9 square roots of 3, and we're subtracting 4 of them. So 9 minus 4 is 5. So we have 5 square roots of 3 left. And that's it. All right, number 2, let's take a look at this. Let's break it down, do a little faster. So simplifying each term, 54 is 27 and 2, 9 and 3, 3 and 3. It's a cube root, so we got to be careful here. It's a cube root. Cube root means we need groups of 3. This is 3 times 3 times 3 is 27. Cube root of 27 is 3. We're going to bring that other 3 down. Almost forgot about that. This 2, the leftover 2, stays underneath the cube root. So it's a cube root of 2 now, not a cube root of 54. We're going to bring the subtraction all the way down. Well, let's keep going with this. We have 9. 3 times 3 is 9. Cube root of 2. Subtracting. The square root of 2 here cannot be simplified, so that just comes down. That's nice. 2 cube root of 2. Cube root of negative 16. So we're going to break this down. I'm just going to simplify it as 16. And that would be 4 times 4. 2 times 2. 2 times 2. With a negative, so now we have groups of 3, so a group of 3 2s. I guess the positive 7 will come down. 2 times 2 times 2 is 8. Cube root of 8 is 2. When there's a negative underneath the cube root of a cube root, we're going to bring that out. So instead of a positive 2, we're going to bring out a negative 2. And what's left underneath is this leftover 2. Another way you can look at that is a negative 2 times negative 2 times negative 2. That is negative 8. Negative 8 times the 2 that's left over on the inside of the cube root would be negative 16, which gets us back to the negative 16. All right, so we still have to look at what we have here. We have cube roots, cube root, cube root. We have cube root of 2, cube root of 2, and cube root of 2. So they're all the same. So now let's look at our coefficients. We have 9, and we're subtracting 2 that are like terms here. That's 7. Oh, shoots. We got to simplify this over here yet. So I'm going to carry this up. So I'm just going to rewrite everything. 7 times negative 2 is negative 14. So minus 14 cube root of 2. All right, now I'm going to look at everything. We have cube root of 2, cube root of 2, cube root of 2. We have 9 minus 2 is 7, minus 4 is negative 21 cube roots of 2. Number 3. Let's simplify. 48 is 4 and 12, 2 and 2, 2 and 6, 2 and 3. Prime numbers, just so I can see them a little better. We have, it's a 4th root, so we need groups of 4. Well, we do have 4 2's. 2 times 2 times 2 times 2 is 16. 4th root of 16 is 2. So the 7's going to come down times 2. It's a 4th root of 3. And then 4th root of 3 doesn't simplify, so that's going to come down. Minus 2 4th root of 3. 72 is 9 and 8. 3 and 3. 4 and 2. 2 and 2. And there are no, oh, it's a cube root. Cube root. We can do this. So we have the 2 comes down, and 3 is going to come down plus 3. And 2 times 2 times 2 is 8. Cube root of 8 is 2. And then the 3 times 3 is going to be left over on the inside of the cube root. All right, I'm going to rewrite this. 7 times 2 is 14. 4th root of 3 minus 2 4th root of 3 plus 6 cube root of 9. All right, let's look at our, we have a 4th root, and we have 4th root of 3, 4th root of 3. Those are like terms. The cube root is not the same, so that is not, so we cannot. Both the cube root and what's underneath the radical have to be exactly the same before you can combine them. So now we have 14 4th roots of 3, and we're subtracting 2 of them. That's 12 4th roots of 3. Plus 6 cube root of 9. And there's your final answer. All right, look at number 4. 28. So 7 and 4. Oh, I can't break that down. 2 and 2. Pair of 2's. That's going to come out with a square root is 2. So 10 times 2. Square root is 7. Plus, let's be careful with this, 56. That's 28 and 2. 14 and 2, 7 and 2. It's a cube root, so we need groups of 3. So that'll be a 2 that comes out, so times 2. And because it's a cube root of a negative, we're going to bring out a negative 2. And what's left over is the 7. 175 is 25 and 7. 5 and 5. It's a square root, so I need 2 of them. Pair of 2's, so there we go. The negative 4 will come down. 5 times 5 is 25. Square root of 25 is 5. And then the square root of 7 left over. All right, let's simplify each term here. The coefficients. 20 square root of 7 plus a negative. I'm just going to make that a subtracting. 2 cube root of 7 minus 4 times 5 is 20 square root of 7. So we have 20 square roots of 7, and we're subtracting 20 square roots of 7. Those are going to simplify. And we're left with a negative 2 cube root of 7. All right, now we're going to introduce variables. Oh boy. So 98, that's 49 and 2, 7 and 7. When it comes to variables, x to the fourth just means 4 x's multiplied together. Y squared is y times y. It is a square root, so we're looking for pairs. Well, turns out we have some. Pair of 7s, so that's going to come out as a 7. The x's, there's 2 pairs, so each one's going to come out as an x, so x times x. And the y's, each pair is going to come out as a y. And is there anything left over that didn't get paired up? Yep, that 2 here. So that's going to stand underneath the square root. The subtraction is going to come down. We have square root of 2. That doesn't. So we have 7x squared y's square root of 2 minus 3x squared y square root of 2. So, all right, this is probably a little bit more confusing. Square root, square root, square root of 2, square root of 2, perfect. We also got to make sure our variables match up. X squared, y, y. They certainly do. So, okay, so we have the exact same variables in the same spots and the same radical with what's underneath, with the radicand being the same. So we have 7 of them, 7, and we're subtracting 3. We're left with 4 x squared y's square roots of 2. Number 6, we have 8 and 5, 4 and 2, 2 and 2. We have a 3, it's a cube root, so 3 2's, that's 8. Because there's a negative, we're going to bring it out as a negative 2. 8 to the 7th, you can bring out 1, 2, 3, 4, 5, 6, 7 A's. You can certainly group it up, but there's also another shorter way. You can take the 7 and divide by 3. That divides 7 divided by 3. You can make 2 groups. So that's going to be a squared or a times a. And then it'll become out 2 groups. How many groups can you take out of 7? Well, that's 2 with 1 left over. So there's going to be 1 a left over inside. And there's going to be a 5 left over also. And there you go. This is going to be adding 2a squared. There's no square root. Ooh, it's multiplication. I didn't see that. I thought it was subtraction. Okay, we got to keep going then. We have 135 is 527. 9 and 3. 3 and 3. Cube root. This groups of 3, so we're going to multiply this by 3. A to the 4th. You can say 4 divided by 3. How many groups can you take out of 4? Well, it's going to be 1. So it's going to be an a that comes out with an a left over on the inside. And so we have a 5a left on the inside. I did see back here I left off a cube root. All right, now we got to simplify all these terms. We have negative 2 times a, so negative 2a squared, cube root of 5a, plus 2 times 3 is 6, a to the 3rd. I'm just making sure everything's right. Didn't seem to line up. 5a. All right, let's take a look at what we have. We have 5a, we have cube root, awesome. We have a cubed, oh no, this is a squared, that doesn't match up. So that doesn't match up, so this is it, that's your final answer. And that is it for addition and subtraction. Come to class with any questions.